let's put the object at right here. Okay, so object initial velocity 1 meter per second, and in 2 seconds object increases its velocity from 1 meter per second to 2 meter per second. Okay, so let's say from 2 seconds to 4 seconds, the object remain with constant velocity, okay, which is 2 meter per second, remain with constant velocity. And from 4 seconds to 5 seconds, let's say the object increases its velocity. From 5 seconds to 2nd second, let's say object keeps its velocity constant. From 7 seconds to, let's say, 11 seconds, object first decreases velocity to 0. From at 7 seconds, the object started decreasing its velocity, and then increases its velocity to -2 meter per second. Here object velocity is 0. And from 11 to 14 seconds, the object velocity is constant. Okay, so what do we do know? We know that the acceleration is constant here. Acceleration is 0, acceleration is constant, acceleration is 0, acceleration is negative, and acceleration is 0. Okay, so now we're going to collect some data. Let's collect the data. Before we collect data, we're gonna divide our graph to A, B, C, D, E, and F. A, B, C, D, E, and F. 6 regions. We are dividing our graph to 6 regions. And here's what we are trying to find. This is T, of course. We want to find the average velocity. We want to find the acceleration. We want to find the displacement. And then we want to draw the AT graph. Okay, then we want to draw the AT graph. Okay, so let's see how can we do that. Average velocity. So what do we know about average velocity formula? Average velocity, I proved this equation in the class. V initial plus was V final over 2. So V initial is 1, V final is 2 over 2, so 1.5. So 1.5. So 1.5. Okay. So now average velocity at section B is 2 plus 2 divided by 2, which is 2. Average velocity at section C is 3 plus 2, 5 plus 2 is 2.5. Average velocity at section D is 3 plus 3 divided by 2, which is 3. Average velocity at section E is, let's see, section E is -2 plus 3 divided by 2. So 1 divided by 2, so 0.5. All right, and then the F, average velocity as F is -2 over 2, so it's -2. All right, now we're going to find the acceleration. Acceleration formula is acceleration at each section. Acceleration formula is Vf minus Vi over delta t. So acceleration at section A is 2 minus 1 divided by 2. So 0.5. Acceleration is 0.5. Acceleration is 0.5. Acceleration is 0.5. Acceleration is 0.5. 0.5. At section B, let's see what is the acceleration at section B. All right, section B, Vf, acceleration is 0 because Bf is 2 and Vi is 2. All right, so and this is 2, so this is 0. Acceleration at section D, acceleration at section C is 3 minus 2 divided by 1, so which is 1. Acceleration at section D is of course 0, because 3 minus 3 divided by 2. Acceleration at section E is negative 2 minus 3 divided by 4. So negative 5 divided by 4, negative 1.25. Negative 1.25. Acceleration at this section F, is easy. Acceleration at section F is negative 2 minus 2 divided by 14 minus 11, and that is 0. So acceleration is 0. Okay, so now we're going to find before we find the displacement, let's go find the displacement. But let's see what is the average velocity entire trip. In order to find average velocity entire trip, we're going to have to find the displacement. So let's find the displacement. So displacement formula is of course half BH, or displacement formula is BH. Okay, that's good. But today I'm going to show you another displacement formula. Displacement formula is initial velocity times delta t. The average velocity times delta t. Average velocity is, so for section A, average velocity is 1.5 and delta t is 2. So displacement is 3. All right, for section B, now we're going to do section B. For section B, average velocity is 2 and elapsed time is also 2, so it's 4. All right, section C, average velocity is 2.5 and elapsed time is 1. Section C is elapsed time is 1, so it's 2.5. Section D, is 3 and elapsed time is 2, so 6. Section E, average velocity is 0.5 and elapsed time is 4, so is it 2? Yeah. F, so F is average velocity is negative 2 and elapsed time is 11 minus 14, so 14, 11, 3, so 3, so negative 6. Okay, so this is our displacement. So let's find the total displacement. I'm going to write the total displacement over here. So this is negative 6. I'm going to write the total 11.5. Average is displacement. So then average velocity 11.5 divided by elapsed time 14.82 meter per second. All right, now we're going to draw the corresponding AT graph. So we're going to draw the corresponding AT graph. Okay, so n1, our lowest acceleration is negative 1.25. So 0.5 from 0 to 2 second acceleration is 0.5. From 0 to 2 second acceleration is 0.5. Okay, and from 2 to 4 second acceleration is 0. 2 to 4 second acceleration is 0. From 4 to 5 second acceleration is 1. From 4 to 5 second acceleration is 1. From 5 to 7 second acceleration is 0. 5 to 7 second acceleration is 0. From 7 to 11 second acceleration is negative 1.25. 7 to 11 second acceleration is -1.25, and from 11 to 14 second acceleration is 0. So 11.14 second acceleration is 0. Okay.